Let's also make a little plan. So we have 10:30 until 12. I'm thinking I'll do a small break in between, like 5 minutes. So 11:15 around there, we'll do a 5 minutes break. So it's gonna be live coding up until 12. So I also want to go through the model, and I think we might need a little bit more time after lunch. Would that be okay for you? If someone needs to go, we're gonna record that part as well. So we'll share all the videos with you later. So, share screen. Let me do this task as well. So I have my helpers. Here is the tick function. So first task was to check if new head has eaten the food. And in that case, we need to generate new food. So we are writing if. We need to compare new head with the food. So new food or old food, they are the same. So we do is equal new head, new food, for example. Then we need to change the value of new food. It will be a complete new value randomly placed on the board. So we call our helper function called generate food. And generate food needs a parameter. If we take a look at this function, it needs a snake because the new food cannot collide with any of the snake cells. This is why it needs a snake. Which snake should we send? Let's send new snake. We already have it at this point. New snake. There. So that's the first bit. Then we have here, this one probably wasn't that hard. So if it goes right, X increases. If it goes left, X decreases. So I'm gonna change this to -1. If it goes up and down, X stays the same. If it goes down, Y increases. If it goes up, Y decreases. There. Now, we go to generate new tail. And first part here is create new tail that should consist of the old snake's head and old snake's tail. So we can either use the concat function or we can use the copy array function. I'm going to show you both. So I'm going to write let new tail equal. First we create an array with the first element in it. And we want the head to be the first element of our new tail. So the old head, right? Not the new head. So we go old snake dot head. And then we can add the old tail as the rest of this array. So then we can use the concat function. The concat function, it doesn't change its parameter, it returns the result of concatenation. So we need to save that result in new tail. So we write new tail is new tail dot concat And then we send what array we want to concat this array with. And that's old snake dot tail, like that. And now this thing is nice to rewrite like that. New tail, you can do it in one go using this spread notation. So first, as the first element, we want old snake head, and then comma. So after this element, we can create an array like that, right? We just give all the elements there. But what we can do here also is that we can take old snake.tail, that is an array in itself. So if we do like that, we actually have an array with two elements. One element is the head cell. The second element is an array. But if we want to remove the array like container around the elements, we use the spread syntax. So it's very similar to how we use it in objects. When you use a spread syntax like that inside, in front of an object, think of it as if you unwrap it. You remove the curly braces and all the elements are unwrapped and placed into some new object. Here is the same. We like unwrap this array, remove the array container, and put all of the elements into this array. So this is an easier way to write this, I think. But if this is too much to wrap your head around, go like that. But this is a very short, nice, and powerful syntax. Looks pretty. So I'm gonna keep it like that because first I assign something to a new tail and then I rewrite it. So I'm actually using this value. I mean, I overwrite new tail. So I'm gonna add both of these things to the code, just for you to see. Okay, and the next bit is, so now our tail, if we compare to the old tail, it has become longer because we have one extra element in the front. And now we want to maybe remove the last element of the tail. And we want to do that if the snake has eaten the food. So we're going to check if, how do we know the snake has eaten the food? Well, it's the new head. If is equal new head to what? To old food. If it has eaten the old food, so not new food because that would generate after we figured out if the snake has eaten the old food. So if that equality holds, then we will take new tail and we call the pop function on it, pop. So this function actually changes new tail. There are some functions that don't change their parameters. Concat doesn't change this parameter, but this one does. So this one does not mutate its argument. This one mutates the array that has been called on. And now the last bit is, we'll just return new tail. There. Let's see if this works. Oh. One more. Refresh. Oh. Yeah, I think I forgot. So when do we need to pop the last bit of the tail? That's if we have not eaten. So I forgot an exclamation mark here. There. I can press my buttons and play. Yep. And my snake will even go out of the grid and says goodbye, but then it will say hello again. And it can go into itself as well, or overlap itself. And that's no problem for it. But that's not how we want to play. That's too easy. This game you can play for however you want, or for how long you want. But if you just leave your snake like this, well, it is gonna go kilometers away from our screen. We can, of course, turn it back, but then we need to wait for as long time as we let it go. Okay, so we have this. I am gonna save it and upload it. GitHub. All right. Next step for us is to add that logic so that our snake cannot go into itself and it cannot hit any walls. So let us see how we're using this helper stick function at the moment. And so what we want is to, I think we want to add a new state variable to our game. We want to say our game is over at some point, right? So right now we have a game. It describes the snake and the food, where they are on our grid. Let's add another state variable that is called game over, just underneath it. And now try to not look at what I'm writing. Write it yourself, but I am gonna write as well. Just don't look at my screen first and then confirm that you're writing the same thing. We're creating a new state variable, game over. Think about what its initial value is. So what should game over be when we start the game?
False.
Mm-hmm. It would be sad if we start off like that, as losers. Okay, so now what I want to do is I want to set this, I want to set game over to true if my snake didn't behave itself. And that we can do after we have calculated our new game state. So let's expand this a bit. And so right now we are sending just helpers.tick, just a function reference like this. So let us make this code a bit longer. So our parameter is old game. Then we have arrow. And then we have helpers tick old game. This code is equivalent to the code we had before. Set game, old game, arrow, helpers tick, old game. Now let's also add some curly braces because we want to do more stuff there. Let us also, so set game, sorry. Oh, I added curly braces in the wrong spot. I want to add curly braces after the arrow that comes right after old game. So I want to wrap my helpers.tick whole game in curly braces. There. Now, helpers.tick old game, it returns the new game, right? Let's go and check. Tick returns the new game state. We first calculated new snake, new food, and then we return an object containing those two. So what we can write then is we can save this in a variable. So we go and write const new game equals helpers tick old game. And then we should remember at the end of this function to return new game. Now it still works the same way it did before. We have just created some space to writing some extra code. So what we want to do now is we want to take this new game object and run some more logic on it. We want to find out, is this new game state illegal? An illegal game state, it means that snake's head is either outside my grid or, and I only need to look at the snake's head because the tail wants, this is the first illegal move that happens. The tail will never go outside of the grid if we first check the head. Are you with me on that? Yeah. So that's one condition, that the snake's head is peeking outside of the grid. And the second condition is that the snake's head, again, we only need to look at the snake's head, that it overlaps one of the snake's tail cells. So we're going to create that logic and let's extract it again as a helper function. So I'm first going to write how I'm using this function and then I'm going to implement it. So I'm going to write if helpers, and then let's come up with some good name for it. Maybe we should just say is game over, and then we send the game state and it will tell me true or false. So I'm going to write is game over, and then I'm sending new game as the parameter. So is game over is going to calculate if this new game state is wonky. What should we do in this case if helpers is game over? Well,
set.
Yes. What you started saying was correct. We want to set game over to true here. Yeah. And then we want, as the result of this whole thing, we want to return a game object. And our question is, what should we return here? Do we want to display an illegal game state? So what can we return? What's the old game state? With a variable holding it. If you look at the code.
Old game?
Yes.
Oh.
This is the parameter to this function. Old game is the previous game state. So we should calculate new game, then take a look at it. Oh, no. I don't want to show this. This will completely confuse my player. We don't want to show to the player that our snake doesn't have a head and its tail is sticking out of a wall. That's too bloody. So we're gonna save them from this stressful and painful experience. And we're gonna return the previous, so the snake is gonna hit the wall and stop there. So return old game. Okay. This is now done. Now we need to go and implement this function. Helpers is game over. If you want to still look at this thing, I think you can do it if I pull it like that. So I'm going to my helpers and I'm creating a new function. It needs to be visible to this file because every function that I'm calling from the outside has to have export word in front of it. Export function is game over. It takes a game object. Now, what do we want to check here? We want to check the snake's head. That's the only thing we'll need. We also will need the snake's tail, right? So we will only need the snake. We don't need to look at the food. So let's take out our snake variable. Let const, we're not going to change it. So const snake is game.snake. And then we need to check, is the head outside of the grid's bounds? And I'm gonna go and create another helper function for it because this is a piece of logic that is very well defined. So a little private function for this file. So function is out of bounds, for example. And then we send in a cell and we know in this file what width and height of the grid is. So we can just use those two variables that we defined at the top of the file. So then we return, and there are 4 different directions we need to check. First, we check the x coordinate of the cell. Return cell.x. If it is less than 0, 0 is okay, that's the first cell. Less than 0, no. So if cell is less than 0, then it's out of bounds. Or if cell.x is, you can write equals or you can write bigger than or equals, because that's also out of bounds if it's like completely way far out. Then what? Then width, I'm hoping you are with me on that. Or cell.y, we need to check the y as well, just the same way. Less than 0, then it is too far up, or it is also cell.y bigger than or equals to what? The height. There. Now we have a helper function is out of bounds that returns that SL is out of bounds. Then it will be true, otherwise it will be false. So it's 4 different conditions and it's either or. All right, so then we can write here, is game over? Well, we can write return is out of bounds, and we are looking at the snake's head. If snake's head is out of bounds, or if the snake's head is overlapping any of its tail cells. And we have written this code a couple times before. Do you remember how? First, we start with an array, which is the tail array. So we write snake.tail, and then we call a function on it to check if there's any cell in it that equals to the head. Sum. Great. This function returns true if there is any element in the tail array that satisfies a specific condition that I'm gonna give it now. The condition is given by a function. So we have cell, for every cell, check. Cell, or is equal, cell, and what are we comparing it to? If tail cells overlap with what?
The snake's head.
The snake's head. So snake dot head. There. Is game over is done. Either head is outside of the grid or it is hitting or it overlaps with the tail. So we have written how to use the function and then we implemented the function. This is actually a very nice practice. You know, sometimes maybe you will write a function that you think you need, and then you jump to a place where you are actually going to use that function, and then you realize, oh, wait, I can't use it like that. So it's nice to pretend that we already have it, write the usage, and then implement it. I don't always do like that, but when I do, I really enjoy it. So game over will be set to true. Maybe we can even do a console.log. Something like you lose. And we should also see on the screen that the snake is not moving anymore. Because we return old game here, we don't update the state. Whoops, okay. Cannot read property sum of undefined. That means that where we called sum, helpers is game over. Something, it didn't find our snake.tail. So it thinks that snake.tail is undefined. Anybody can help me? Oh, I'm not running my code. I just open an old page and if I refresh, it didn't work. Okay, snake. Okay, welcome into the wall. Yep, it hit the wall and it stopped. If I check the console, it said you lose many times. You see? It says you lose many times because my timer is still ticking. It's still updating, calculating the new state. Every time it calculates the new game state, we get a position of the snake where it's just outside the grid, and then we check, is that good? No, and then we return the state. But we continue, we keep checking our, the timer keeps ticking. Do we want it to work like that? Nope. We are spending some valuable resources right now. And it's actually, do you know actually, like, is it your computer working? Or is it somebody else's computer working, like Google's, where the site is deployed? Whose computer is doing the work now?
I think it's my computer.
It's correct, yes. Because what happens is we download basically all of the code, all of the JavaScript code with the help of our browser. And it's the browser that is doing the work. So if we do some heavy stuff in our JavaScript and it's client side, so to say, you are the client. When you open this web page, you are the client. And yeah, some pages are heavy. Have you ever had, like, seen when Chrome or any other browser takes super much memory and resources of your computer? That's because their JavaScript code is crazy. So we want to be kind to our clients or to our users and not make their computers do some unnecessary calculations. So we're going to go to index.js and we're going to stop this timer. So this complex use effect code is going to get a little change now. When do we want to stop the timer? What variable can we use in order to check if we should continue or not?
Game over.
Game over, exactly. So then we add this to the dependency array of this use effect. We say use effect depends on game over. Okay. But actually, this change only, it's not giving me right away the effect that I want. Why? Because, okay, this function will run every time game over changes. It changes, well, the first time this thing will run is the first time we render the component. That's when game over gets its first value and it's false. And what we do then is we create an interval and it starts ticking. We also say, here is how you clean up this interval. What happens next is game over changes to true. This function will be run again. What does it do? Well, it actually creates this function. I'm sorry. It's gonna create another interval. It doesn't check, is it game over or not? It's just gonna go ahead and create another interval that will update our snake. But yeah, what it does is that it returns old game here. So now we actually have two parallel processes ticking. Both of them are checking the snakes. Both of them are calling the helper stick function and realizing, no, we're not updating the snake. So we have two intervals. That's not good. But was I right saying that? I don't think so. I'm gonna rewind. So look, This is complex, even I get confused a bit. But if we just rewind, game over is false in the beginning. This code is run. We create a timer and we say, this is how to clean it up. Next, what happens? Game over changes to true. We clean up the previous timer. That's what happens. And then we create a new one. That's what we don't want to do. We don't want to create a new timer when game over is true. The way to fix it is easy, is to create an if statement saying, if game over is true, if game over is false, then create interval. But it's also easy to just write if game over, don't do anything, return. So this is a guard, which is, it's guarding this code from running when it shouldn't. This is hard, but if you have at least some kind of hint, some kind of clue of how it works somewhere, you know, you can almost reach it. I'm happy because this took for me quite some time to understand. And when I have done this game 4 times, then I am quite confident in what I'm doing. First time I was using useEffect, I just looked, you know, at somebody else using it and I guessed, you know, oh, maybe I should use it as well. And then I built something more complex and I realized, oh, something is buggy here. I don't really understand what this works. And what the hell is this second argument? This was my path. So then I went to documentation and I read about those 3 cases for the dependency array. I understood it, I got happy, and then I started using it more and it became better. But still, I encountered the problem when you create an interval, leave the component, and React says, you have a memory leak, my friend. You did something wrong. And I was like, what? My memory is not leaking. And then I read up on that and learned about the cleanup function. Oh, you need to clean up after yourselves. So you see, like this useEffect hook, it has lots of different bits and pieces to it. It is hard to puzzle it out, to, you know, find exactly how it should work. But something that really clears your head is you make some kind of try. Like, okay, this is, I think, how it should work, but something is maybe wrong. Make a table like this. It's kind of crazy, but I don't know. This table makes me happy. Because it's so clear to me when I look at this, what's happening, that I'm not afraid of inviting 13 people to a JavaScript camp and explaining this to them. This is how happy this table makes me. So I am really hoping that you get at least a hint of how this works. And I'm not expecting you to understand it fully because, well, I didn't the first time I looked at it. So I'm not expecting you to be superhumans with super brains. Okay. So we have now finished the snake game. Yep.